It's okay.
That's so true.
They're in the same problem.
Really? All right, guys, I think I'm gonna go ahead and get started here. That's not.
Oh, it's a different problem. Okay.
Yeah, I'm just gonna. Let's go ahead and get started. Again, I'm shouting to the back. I do encourage you, if you're feeling like, oh, I could maybe be doing a little bit better in this stuff, I would recommend moving up. You can be less distracted, right up with everything like right in your face. So it's up to you, but if you're fine where you are, that's totally fine. I just want to remind everybody, we do have an exam on Tuesday, right? And so I have office hours on Sunday and on Monday and on Tuesday. See, I'm losing my voice. Thanks, guys. They're getting my subtle hint. That I like their company a little better up here. Yeah. So we have an exam coming up on Tuesday. Don't forget, I'm doing review sessions. So I'll just remind you here that my reviews are going to be on Sunday from 7 to 9. And that'll be here. Okay, awesome. And then on Monday, I'm gonna go from 5 to 7. These review sessions are not required. I will take video of them, and I will also be in Zoom recording these sessions. So if you want to watch from home, you can. I'd love it if like somebody would show up. But if I'm here in the room by myself, I'll just do it by myself. And then I'll send out the link to the review sessions after the session is over, okay? So don't feel like you have to come. Also, the problems that I'm gonna go over are in that review packet in the resources folder. I solved out those problems, so there's typed out solutions to the review session questions as well. So if you'd rather just try them on your own, you can do that. Is there a question?
Yes, for the review question, there was a question where it says consider something about hands and all face cards, and you counted aces and tens as face cards.
I did?
Yes.
Okay,
Well,
well,
it was listed out. Should we?
I don't worry about that. Okay, so I'll explain like, so I guess, I don't know why I called those face cards. That would be debatable, what would be considered a face card. So I would have to, if I ask you a question about poker cards and you're not sure, like, oh gee, I don't remember like what a flush is or 3 of a kind or whatever, you can ask me during the test. Okay, so yeah, I might have been a little bit making too many assumptions about that there. But anyway, so getting back to this, I'm gonna do these 2 reviews in person in this room. I'm gonna record them, I'm gonna email them out. So if you wanna watch them, you can, but you can also just discard them and just do the problems yourself if you wanna use it as a practice. But there's also 2 practice midterms in that same resources folder. I would highly recommend everybody do at least one of them and try and do it as a real test. Like give yourself 75 minutes and sit down and see how well you can do. You'll notice that my exams have usually lots of parts. It's because I don't like any one problem to be able to like ruin somebody's grade. But it also does mean that there's a lot to do there. I may give you a take-home portion of that exam. You'll notice that I did that last year. But I have not written the test yet, so I don't know how it's going to shake out. Hopefully I'll come up with something pretty reasonable. It's going to cover chapters 2, 3, 5, and 6. Those are the 4 chapters that we have covered. And all of the topics are outlined in that review packet that's online. So I think I won't say a lot more about the exam right now because you guys are all capable of looking at the folder and you're all pretty good at, being students. You've been able to make it to Math 471. So I don't think I need to like handhold you too badly through all of that preparation stuff. There is a homework assignment that's due tonight. Don't forget I have office hours after class. I will be downstairs most of the evening except for a dinner break. So if you do want to ask me anything, you can do that, and then there won't be any more homework due until probably the week after next week. I'm pretty sure there won't be. We'll have the exam on Tuesday, and then there'll be a little bit of a lull while I get things graded and stuff. So when we come back from the exam, we'll be jumping into chapter 7, which is about recurrence relations. So that's definitely coming up next. Any questions about that? So homework for tonight, I will get it graded as soon as I can, and I'll post the solutions as soon as I can for this homework. And then everything should be up. The group works, the homeworks, the review packets, everything should be ready for you to look at. If you find any typos in my packet, let me know. But I think I've taught this class enough now. I think I've cleaned it up pretty good, but you never know. So, okay, if we're all good on that, I will, and I'll also send you an email this weekend to just kind of remind you about everything. I would like to come back though to where I left off on Tuesday. I almost finished this, but I want to do at least an example of it. And there are 2 homework problems for tonight that use this idea. And it's the forbidden positions problem, where you're trying to write down a permutation, but certain numbers can't go in certain slots, right? And if you have several of those conditions, then it's really going to be set up for inclusion exclusion. And that is formalized in this equation here, this expression. You will want to memorize this, by the way. You will want to memorize the number of solutions to the forbidden positions problem. You basically take all possible permutations of n objects and you subtract violations. But those violations are expressed as a union. And so as we know, the inclusion exclusion principle applies to that. And so you're getting these alternating subtractions, additions, and so on. Let me just, well, I guess I'll throw up this example, and then I'm going to explain these R's a little bit better. I didn't really have time to really do a good justice on that last time. So today we'll try and do better with that. In a nutshell, what they are is they are the number of ways to violate I conditions. So you have as many as n conditions because there's forbidden positions in each position. There's n of those. And so the R sub I is counting the number of violations of I of those conditions. Let's try this example and see if we can make sense of it. What does this say? How many permutations of 4 numbers are there such that 1 and 2 are forbidden from the first position, 2 and 4 are forbidden from the second position, 4 is forbidden from the third position, and 1 and 3 is forbidden from the fourth position? The first thing you're going to want to do is draw a little checkerboard picture of this. I did do this last time on an example I was working on. In this case, it will be a 4x4 grid. So you're going to have 4 rows and 4 columns. Let me go ahead and make 4 rows and 4 columns here. And my positions are just going to be set apart by the rows. So the first position is the first row, the second position is the second row, the third position, and the fourth position. So the positions are in the rows. Actually, it turns out, I should point out, it turns out if you want to do the positions as columns and reverse the roles of the positions versus where the positions, the forbidden spots are, you can do that. You can transpose this grid and you'll get the same answer. But I just like to do it the same way every time. I have 1 and 2 are forbidden from the first position. So the actual numbers that you're putting into those positions are going to go in the columns. For position 2, 2 and 4 are forbidden positions. And then 4 is forbidden from position 3. And 1 and 3 are forbidden from position 4. So this would be the picture that would go with all of these words. And the question is asking us, how many ways are there to put 1 dot in every row and column, but without touching an X? Okay, so, you know, there would be, as just an example, I could do something like this. I could pick that one, that one, that one, and that would work. And this would be a 4 in position 1, and then a 1 in position 2, a 3 in position 3, and a 2 in position 4. So the thing I just drew in blue would be one example of how you could successfully avoid all of the forbidden positions. You with me? Now, when I'm doing this, you'll notice that we're talking about permutations, which means I'm not going to have the same number more than once. So if you cannot put two blue dots in the same column, because that would mean that you wrote down the same number in more than one place over here. And that would not be a permutation of 1 through n. So right from the beginning, guys, this n factorial is taking that into account. It's taking into account that you're not putting two dots in the same column. So I'm emphasizing that because when we subtract violations, I don't want anybody thinking that two dots in the same column is a violation. It's actually not. It's not even been counted in the first place. Okay, so you're only going to be working from things that are legit permutations to begin with, right? And so as we start thinking about what's being subtracted, we have to understand that we're only subtracting things where the dots are in different rows and columns. Okay. So yeah, this n factorial is the total. So for this problem, we would start off with 4 factorial. And we would start subtracting violations. Now, what kind of violations can we have? I wrote this down on Tuesday. We can have a violation in the first position, or the second position, or the third position, or the fourth position, right? So you could have A is a violation in position 1. And then B is a violation in position 2. And C would be a violation in position 3. And D could be the set of violations in position 4. Right? So what would be like, so the first thing that you subtract when you do inclusion exclusion is you subtract the sizes of each set. Because these, if you're having a violation, it's going to happen in one of these positions. So you're really trying to, you're going to subtract the size of this unit, yeah? Right? So that is what you're looking at. So the first term is going to be to subtract the individual sizes of the sets. So let's talk about what is the size of A. Well, the size of A is, well, I have to have a violation in position 1. So that means I actually have 2 choices for where that violation is. And after I've done that, after I've made a violation, let's just imagine, okay, is it okay if I kind of, let's say I chose this X. Then that means I'm never going to choose that column again, and I'm obviously done with that whole row.
Mm.
What I'm left with is a 3x3 subgrid, of which I don't care at all about rows 2, 3, and 4 in terms of violations. So how many ways are there to put 3 blue dots in the 3 remaining rows that I have and the 3 remaining columns? That is simply n minus 1 factorial, which in this case would be 3 factorial. Agreed? Your 4x4 grid has reduced to 3x3. And so that would be the size of A. Now, similarly, the size of B, well, there's only one, there's 2 squares there also. There's 2 squares in the second row where I could make a violation. So I'm just using the multiplication principle. Create a violation in row 2, 2 ways to do that, and then fill out the rest of the rows. There's n minus 1 rows remaining, and there's n minus 1 dots remaining. Fill them out as a permutation. I still have to preserve the permutation nature of that. Okay, and then the size of C would be, there's only one X in row C, or in row 3, so there's only one way to choose a violation in row 3, but then I still have 3 more rows and 3 more dots, and I'll have 3 ways of arranging those. And then finally, the size of D, well, there's 2 X's in row D, so there's 2 ways to make a violation in the bottom row, and in doing so, I now have 3 more dots to put into 3 more columns. Are you with me? So now, what is all of this being subtracted? If I subtract all of it, aren't I just taking these numbers, which add up to 7 times n minus 1 factorial? That is what R1 is. R1 is the number of ways to violate one condition. Well, I can either violate this condition or this condition or this condition or this condition, and I'm simply adding those up. So I would be subtracting 7 times 3 factorial here. That would be for this term right here, right? So R1 is 7. Okay. Now, as we all know, that is going to have resulted in a double subtraction. I'm gonna redraw the picture over here because I've kind of made a mess of the one that I have over there. Let me just redraw this one time. So this is my picture again. Okay. So I now have to realize that I have subtracted some of the scenarios twice. So if there was a violation in positions 1 and 2, then I would have subtracted that configuration here and again here. That's a double subtraction. I need to add it back in. So I now have to add back in sort of the two-way intersections. Let me just talk you through a little bit of that as well. A intersect B. So violations in position 1 and in position 2. The question is, how many of those are there? Well, I've got let's use this picture here. I want to create a violation in both of the first 2 rows. That means I have to choose one of these x's and I have to choose one of these x's. How many ways are there to do that? Just these 2 rows.
4 choices.
I can pick this x, right?
Yeah.
And then
And that one.
I can also pick this x or this x.
Yeah.
That would be 2
That's 2
ways.
choices. And
Or I could pick this x. By the way, I'm doing all of this in my head. Right? This x cannot be
Oh,
picked
duh.
with the x directly below it. So it's actually just this one and this one. There's only 3. See that?
Yeah.
There's 3 of them. So I'm gonna call that R sub 1, 2, which is 3. And so that would be 3. And then after I've picked those 2 violations, I still have 2 more columns and 2 more dots. So what I'm left over here with is n minus 2, which in this case is 2 factorial ways of permuting the remaining 2 dots in the remaining 2 rows. So like, let's say I picked this x and this x. Now my remaining dots have to be picked down here. And I have 2 factorial ways I don't care if I make a violation in rows 3 and 4 or not. I might and I might not. I only care that I definitely had a violation in position 1 and 2. With me? Okay, but then I could also do 1 and 3. So R13, I'm gonna write it as R13. What would that be? That would be making a violation in row 1 and in row 3. How many ways are there to do that?
2.
You have to pick this x and either one of these x's. That's 2 ways to do it. And so that would be a 2. Okay, and so the size of A intersect C would be 2 times n minus 2 factorial. Right? And you keep going like that. Right? So there'll be, let's see if we can work all these out. What would be R14? Somebody tell me, how many ways could I make a violation in the first and last row? 3? Would you guys all agree with that? I can pick this x with this x, or I can pick this x with either of these 2 x's.
Yeah.
Okay, I can't pick 2 things in the same column, so this is also 3. All right. And what about, let's keep going, let's do R23. How many ways are there to make a violation in the middle 2 rows, both of the middle 2 rows?
1.
I have to pick this x, which therefore forces me to pick this
Yeah,
x. I can't pick both of these. So there's only one way to do that, right? Only one way. And then what about R24? Well, I've got this x potentially with either of these, and I've got this x potentially with either of these.
4 choices.
That would be 4 ways, right? 4 ways to do that. And finally, R sub 3, 4. The third and fourth rows, how many violations could I make in both rows?
2.
Sorry, 2, right?
2.
Yeah, this one with that one, or this one with that one, it would just be 2, right? Now, Every single one of those is being multiplied by n minus 2 factorial. Those are all violations. And if we factor out the n minus 2 factorial, then effectively, we're gonna be adding all of these up to create our next term of our formula. If I add all of these up, 3 plus 2 plus 3 plus 1 plus 4 plus 2 is 15? 15, yeah. So 15 times 2 factorial, and guys, this is R2. So I like to think of the R2, R2 is really just, well, it's a sum of 6 other numbers over here. So all of these together, if we sum them up, we get R2. This actually isn't really that hard, it's just tedious. And actually, you probably already figured out that, you know, all you have to do is make one mistake. And your whole thing is off. Right, so you have to trust me, I probably will have one of these on my exam, I usually do, but I'm not gonna be like destroying your whole exam based on like, oh, they got a 4 instead of a 3 in one of these numbers, I probably wouldn't take off of that. Or if the worst thing I would do, if you missed several of them, I might get out my red pen and say something, maybe something's wrong, but I'm not going to be too fussy, because this is really just, you're really just playing with this grid and doing those kind of things. Yeah.
So I have just a quick question. If you have enough like forbidden positions, wouldn't it be like more beneficial to just count the solutions first? Or
As we're gonna see in a minute, when we get the answer here, yes, this one you could probably just write out what the correct solutions are. You're absolutely right, yeah, it would be almost, instead of subtracting violations, just count what you actually wanted in the first place. But in terms of sort of making it fit with the inclusion exclusion principle, we have to do it this way. That is a good point. What about the three-way intersections? Now it gets really interesting. So now we have to take, so you've kind of got the idea, guys, that for R3, I'm gonna have an R123, an R124, an R134, and an R234. You're gonna have all of those combinations. And each of these is going to be a violation in 3 out of the 4 rows. So can somebody tell me how many ways are there to make a violation in all of the first 3 rows? I'll give you a little hint. If there's a row with only one X
Yeah.
in it, you must pick
You
it.
must pick it.
And as soon as you must pick that one,
Pick
then
that
you can't pick this
So there's
one, so
one.
you must pick this one.
There's one way.
And as soon as you pick that one, you can't pick that one, you must pick this one. How many ways were there to do that?
One way.
1, exactly. And this one is a 1. Okay, excellent. Let's go to 1, 2, and 4. Now, what I sometimes will do is I'll just try to be systematic about it, and I'll say, all right, let's figure out all of the violations where I specifically use this corner, right? If I do that, and then I'm looking at rows 2 and 4 as well, I can see that in the 4th row, I would have to pick this X. But in the 2nd row, I can pick either.
So that's 2.
So that would be sort of 2, but that's not the whole thing. I've still got the possibility of picking this X. If I pick this X, then I cannot pick this one because it's in the same column. I must pick this X. And then in the bottom row, I have 2 choices, right? So it's actually 2 plus 2. If you just wrote 4 there, I would be okay with that. Let me know if I'm going too fast. It takes a minute to get used to this. For 1, 3, and 4, I actually have to pick this X. And then in rows 1 and 4, well, I can again do either this pair or this pair or this pair. 3 ways. Okay. And then in rows 2, 3, and 4, well, I'm gonna have to pick this X and this X. And one of these 2 X's, there's 2 choices there, so that would be 2. And I add all of that up and I get 10. Each one of those 10 violations has n minus 3 permutations of the other dots left over, but in this case, n minus 3 is just 1. So it's 10 times 1 factorial. And last but not least, there is one more term, which is creating a violation in all 4 rows. Can we do that? Notice I keep going to
Yeah,
this row
rid
first,
of that one.
because there's only one X. I have to pick this X,
Yeah, you could.
which forces me to pick this X, which forces me to pick this X, which actually forces me to pick this X. There's only one. There's only one. So you would add 1 times 0 factorial. And so what is this going to come out to? 24 minus 7 times 3 factorial is actually 42. 15 times 2 factorial is 30. And then minus 10. And then 0 factorial, by the way, is 1 by convention. And let's see, I think that comes out to 3. So Jose's point is well taken. We could have just written out the 3, could just find the 3 ways of doing it that do work. And it would have been a whole lot more direct, but it also would not have been using our theorem that I like to use. So this is one of them. Can we figure out what the others would have been? I'm just curious. Obviously, if you get a negative number out of something like this, you know there's a mistake. You can't be expecting negative answers. That reminds me, by the way, if this was on an exam, I would accept this just like this, right? Now, if you have extra time, I would recommend actually doing the calculation if it's not too bad, and just make sure you get a reasonable answer. But if you don't have time and you just leave it like this, you're certainly going to be showing me enough work that I'll be happy with that. So how else could I do this? I'm just curious. Well, I could do a dot here, 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 and here. All right, so that one would be 4, 3, 1, 2. And then there must be another solution somehow. Probably I have to put the blue dot here, which means I have to go here.
Yeah, one.
Because I have to go here and then I have to go here, right?
Yeah.
Does that look good?
Yeah.
So that's 3, 1, 2, 4. There are the 3 ways of doing it that avoid the X's. Yeah, so if you could actually list them out in this case. Yeah. All right, so this is just a generalization of the derangements problem. And you can see how that works. It'd be a little exercise you might try over the weekend if you're bored, is to try to do the derangements problem using the forbidden positions formula. And see if you still get the same answer as what we got for the derangements on Tuesday. So we have a formula for D sub n. By the way, you're allowed to write this in your answers. So if it says how many ways are there to put 7 objects that are all in the wrong positions, you can just write the answer is D7. You don't have to like work it out.
Okay.
That's an okay expression to use. But anyway, what I was gonna say is, you know, the derangements picture is really just X is going down the diagonal. And it actually, because there's only one X in each row, calculating these R's is not so difficult for the derangements example. So you could actually figure out that, okay, yeah, this R1 is gonna be exactly N. And then the R2 is gonna be, you know, N choose 2, it's stuff like that. And you'll be able to actually rederive what we had already figured out last time for the derangements formula. Kind of an interesting thing. You guys get it? Kind of get it? When it gets messy is when there's lots of X's in the picture, and well, especially when there's lots of rows in the picture. So I've got one here. By the way, if there's a row that has no X's in it at all, you can kind of just ignore that row. You're never going to have a violation in that row. So you kind of just, it's almost like that row isn't there. So like if, for example, if row 4 didn't have any X's in it, then these would all be zeros. You would have no violations that involve that row. So some of the terms could be quickly knocked off. I'm mentioning that because I now have a 6x6 problem for you guys to try. Jose?
Also notice that you have 2 rows with like only one position, it also, right? So like if you have like, for instance, if the 3rd and the 4th only had like they're back to back, right? And they appear. Like in the homework was one of them.
Okay.
Where it's like you have 2 of them, like you can only take like, let's say like the same position. like.
Oh.
Row.
Yeah, you mean the same position in the same column.
Yeah.
Yeah, that's not allowed. That's not allowed. You can definitely exclude that for sure. Well, anyway, I'm gonna let you guys practice. Yeah,
So
Tamara?
then our sets would drop down by one if there's not a violation?
Yeah, you could actually just not even include it and just make your problem that much smaller. Yeah, that's perfectly fine. Or you can include it and then just have all these zeros here.
Okay.
And that's also, you're gonna get the same answers either way. Yeah, that's a good point. So I want you guys to just try this with your friends. Let's just make sure everybody can do good conditions. Whoops. How are you doing, Katie? Nice to see you. Worried about you. You good though? All right, guys, grab 2 or 3 friends, anybody you want, and see if you can work out these problems together. I'll come around and give you a hand. I certainly do. Do you? Yeah, you know those guys? I actually kind of like the older stuff better, actually. Yeah, like I love. Kind of what I grew up with. But yeah, it's these days it's kind of drifted into. Yeah, it's poppy and or sometimes.
Yeah.
But I still, like, I really like, you know. Yeah, so some of that era.
Some have some songs there.
Then midterm day, everybody gets.
Some songs that.
Well, that's what I love.
Yeah.
Yeah, like, there's some really good messages in the songs, that's actually what I like about it. Yeah, so you're absolutely right about it.
I love your parents. I love something. Oh my God.
If we ever go on a road trip, we'll know what to put on the car. Okay, let's see.
Yeah.
We know how it's already back.
Ally, I never gave this back to you. And
Now we gotta calculate.
Counting time.
oh, I dropped my phone.
Yeah.
Oh, no. Or whoever's in here is getting busy. Okay, thank you. Group work number 6.
Well, that's really too busy. Yeah. I can. But I'm just like, let's just do it as we did it.
Are we going? I was just gonna start like.
So. Yeah, that's it. Thanks for
Doing the general form of it.
It says. Okay. I got these are fingers, man. This is all this, alright, so we're saying it's a violation of R1, do we have to pick this?
That's one, that's only one can do that.
Oh, wait, how about is this one yet? See, but we gotta pick. Oh, we're not doing intersection yet, so it's only one way.
Well, one and then, I guess, yeah.
Do we want to do the R1, the R1, 2, R1, 3, blah, blah, blah?
Yeah, right about, yeah. Yeah, so we're gonna have for R1, we can do this one for now.
Yeah, well.
We can say what it is, it's gonna be 5 factorial, because we know n is 6. So we can put 1 times 5 factorial, make it easier. And then for E, there's 3 choices. Yeah, so 3 Oh, we can just add them. We don't need to write them.
Yeah,
We can just say 3, 4, 5, 6, and 15, right?
This
Or-
one is
That should be
the-
R1 should be 1 plus 3 plus 2 plus 1 plus 1.
Oh, everything with my start and stuff.
Yeah, that's 8.
I'll try it that way. R1.
Yeah.
Because it's.
Yeah, I was trying to do my head. So we're doing 1 and 2?
Yeah.
So for 1 and 2, we have to pick this. We have 2 choices. And then for 1 and 3, we have to pick this. We have 3 choices. 1, 2, and then 1, 4, we're picking this. We have 1 choice. We have 1, 5. We have,
That's what I got. I do have the answer.
we don't even need to do 5. We don't need to do 5 at all.
Run over and check.
1 and 6 would be 1 choice.
Yeah.
Okay, so we add all that together, that's 6.
No.
Okay, cool. And then now we're gonna do the triple intersection.
Wait, what? Oh.
Yeah. because
Oh, wait,
Oh.
I see what you're saying, yeah. 2, 2, 2, 3, okay. Okay, so for 2, we can cover this guy up, we have 2 choices. Cover this guy up, we have 2 choices. We have 6 choices total.
Yeah.
Yeah. Or 2, 2. 2.
So each one of these is
We
like,
have 2.
you know, 10 counting problems. Yeah.
Alright.
This should just
Now
be
we
the whole
have
exam.
I know, the whole exam is just.
2, 4, we have this guy, this guy, this guy, and this guy, so we have 3 choices. Three choices. We pick him and him, him and him, him and him.
Yeah.
I choose.
2 and 6.
2 and 6, yeah, we don't need 5. 2 and 6, we have 1, 2.
That's the right one, 21. I like it.
2, 3 is 6, yeah, 'cause we had this guy and this guy, this guy, this guy. This guy, this guy, this guy, this guy, this guy. 6 choices. 3, 3, 4, we have 1 choice. 3, 6, we have this guy, this guy, this guy, this guy, 2 choices. 4, 6. 1 choice. Okay. And then we can't do 5 and 6. Okay. Alright, I think that's all the duos. What is that adding up? 4, 5, 6. So.
Yeah, we're missing one.
21? Yeah.
That is right, and I've actually got it on my board there, so if you look at problem one, I put the solutions up so people can check their answers.
I see.
So that was supposed to be. Excellent.
Wizard abilities.
No. Die. The wizard.
This is the one that's interesting.
So we pick this.
You have 10. Okay, that's good. Okay, go to it.
3, 4.
Oh, wait, no.
Yeah, I got 4. I love them.
Good.
Yeah, 4. I chose this guy, which means I have him and him, him and him and him.
It's
Him,
2.
him, and him, him. Yeah, I got 3.
1, 2.
Yeah, I got 2. We can choose this guy, we have to pick him, which means we have to pick him.
Yeah.
One, two, 1, 2, 4. So picking him.
Yeah.
So then we can pick any of these, but we pick him. That's 1 choice. 2 choices, 3 choices.
Wait, 3.
Pick this guy, and you pick this guy. Oh, wait, yeah, you can't pick him. So we can pick him, yeah, 2 choices. You're right.
Yes.
Cause I forgot you. 1, 2, and 6. Oh my boy. Okay, we picked the 6.
Oh, this one.
Just.
Maybe it's
Or we pick him, which means we have to pick him, but we can pick 1, 2, 3 choices.
Yeah.
3 choices, I got it right? If we pick him, we have to pick him, and then we have these 3 choices. Oh, yeah, they're not like that. And then 2, 3, and 6, yeah. Same idea, we pick him,
This is R2.
and then
Okay,
we
so
have
these are the
this
two
guy and that guy, and that 2 choices.
Yeah.
We can pick this guy, this guy, and this guy.
Yeah.
We have this guy, and that guy.
Because
This guy. And then we have that guy, this guy.
that looks good.
And if that's not, no, that's more, I don't know. You said that?
Wait.
Oh,
Oh, wait, no. No,
okay, I'm scared.
2, 3.
21, find my math, 21.
Okay, so we have to pick him again.
Yeah.
And then we pick him, and then we have one. Alright, so we added up a. 15? Oh, no, what did we do wrong?
4, 2, 3, 6. That's what I'm wondering. You only have.
1, 2, 3, 1, 2, 1.
I was trying to do.
Where's 2, 4, 6?
Yeah, we don't have 2, 4, 6.
And,
We're missing a couple terms.
yeah, there's at least a 2, 4, 6.
Oh, 1, 4, 6, we were missing.
And 1, 4, 6. You got a couple more to go.
1, 4, 6.
Couple more to go.
Oh, no, wait, not like one, we're missing a lot in the north actually, like 1, 3, 4, like 1, 3, 4, 1, 3, 6.
We got rid of 5.
Sounds good. No, you're doing great, you're doing great. No rush.
I can't do it. Yes.
This is what I-
5 times 4.
Okay.
I think that's all.
What, I didn't slouch during that.
4 ways, really.
5 streets.
You need to have like
5 back.
4 hands, like point to your.
So you're gonna have, yeah, you're gonna have 5 times 4 over 2. No, 5 times 4 is 10.
So.
It's 5 more.
Yeah, it's a little bit.
So this becomes 5 times 4 over 2. So you get 20 over 2.
1, 2, 3. I agree, yeah, just 1 because of the block.
I was thinking the same as my weight.
Yeah.
Yeah.
There should be 10 total.
Yeah, it should be 10 turns.
We got rid of the 5, yeah, which was good. We had to pull up the back.
That's all good, it's all good.
1 way.
Yeah, I had that one memorized. 5 choose 2 is 10.
Oh. 2, 4, 6. We'll pick the 6 guy, that helps. So there's, you have to pick 6 options. And there are 2, you have
Just 2.
1, 6,
5.
7, 8, 10, 11, 18, 21. We did it.
Like we did go 5, there isn't a.
This is exactly what we're supposed to answer. 9, now it's. Triple, oh my. Can I go ahead and I don't want to diss team, but I gotta go.
4 fingers.
I'm quick, I'm going after you.
1, that one's.
Wait, is that all? 1, 2, 3.
3. 4.
I was thinking maybe going down
Okay.
Yeah.
I guess.
No, there should be 5.
I think so.
Now.
I choose.
Yeah.
Or 5, 3, 4.
Oh, there should be 1 more, yeah, okay.
Yeah. That's what we want to do. That's the 6.
And then 2, 4, 6. And that's
For 2, I can really.
Yeah.
Yes.
Oh, 1, 2, 3, 6.
That's just
2.
Oh, no, wait, sorry, we already have it, my bad.
So-
Yes, we do.
Are we missing 5 or 7?
Oh, we are missing one, right? 5, 2, 4 is 5.
1, 2, 3, 4. 1, 2.
Yeah, I don't think so. According to my shows on the second problem, ours is right here.
Oh, 1, 2, 4, 6. 1, 2, 4, 6.
Oh, yeah.
That makes Great. What'd you guys end up getting for R3? Ah, yes, that is right. That is right. Excellent, excellent, excellent.
That's the hard part.
Yeah, it would also be easier just to.
Yes.
No, I don't know if I.
Make like, yeah, on the to. So one you start from here, right? So this means.
So that means I am forced.
I think it's just two. Yeah.
That's these two.
Is that?
Yeah, this one. Three, I have to. By like.
Two, three.
Guys, and let's do some more.
One,
2, 3, 6, 4.
Oh.
Start from here.
Oh, yeah.
I have two choices.
Oh, yeah.
We have this, this, and this, right?
Yeah.
That's one choice, but then we have this. So I have.
Yeah. I think that. I think just one.
So you have to choose 6 and 4.
Yeah.
Then you have to choose 3 and then 1. And then 6, 4, 6 and 4 again. We have to pick that, so 1 again. Oh, no. Yeah, 1, because there's only one position.
Yeah.
2.
I think it's just one.
1, 2, 4, 6. Oh, 2. We can choose either one of these.
Yeah. Wait, I mean, that's, if you. How are you right?
Oh, yeah, okay, yeah, you're right. My brain is totally scared that, yeah. So okay, please don't do a 6x6.
I figure, if I want to run a 20-mile race, I'm gonna practice by running 30 miles, right? I want to make sure I'm really trained up on this. Yeah. Yes.
Oh,
Yeah, one choice. Okay, I'm happy with that.
I think just two choices.
Two choices on that one. Yep, that will add up to 8, so we're missing.
Actually, you're not.
Oh, we're not?
No, I screwed up.
Oh, you screwed up.
Yeah.
Okay. I'm like, no, we're just saying.
Yeah, no, I think it is actually supposed to be 8. I've been checking with the other groups and I realized I have a typo.
Okay.
Yeah.
Alright, it is 8. All 5, huh? Well, pick 6, pick 4. Pick 3. And then we have to pick one of these, so we have 2 choices.
If I believe,
We can pick this guy. Oh, wait, no, we have one choice. We have one choice. Because I can't, my eyeballs keep losing track of the ones that are spread apart. How many of that? Yeah, he had one choice.
R60, I'm not quite seeing it.
R6?
Yeah.
Because there's no forbidden position for all 6 choices.
Oh. Yeah, oh, okay.
4 ways to do that. Okay.
There you Alright, Paul, you're gonna need a human calculator. Let's see what you got. Do it all on your head. Go. Oh, it's 158. No, it's not 158.
Oh, here it
Wait, what?
is.
It's a typo. The 9 is supposed to be the 8.
I think there might be.
Oh, you're right. Okay.
I think it's only 2.
Right.
That's the issue. The roads are just. I got mine.
Okay.
And then there's no ways to make 6 violations. This should be a little easier.
It's all you.
We don't need it. I don't think.
Oh my goodness.
I've prefer it's 20.
No, it's 6. 6 I vote. It's, yeah, it's where they're.
Four factor lives with you. Oh, yeah. This is right.
It's the same.
Wait, so this is 25, so.
No, this is 24.
Yeah, yeah.
24.
Oh, it's 20.
This
Yeah,
is
yeah.
1. There's no 60.
That's a pretty good start.
This is.
Try number 2, you know, it's actually.
I'll pull the calculator.
I have a question. Do the people, are the people, like,
Well, you know, that's. So, what we do is.
That's not easy, but it's secret.
For which one, which way you go for the rows and columns.
That makes me involved in either 5.
So that's a good point that I should find for everybody is that be mindful about how you're setting up your rows and columns. If you can make a row,
Oh, I see.
you want
I
to.
was like.
So
Oh, wait.
you would prefer to set up your grid
Then it's
so that
6
you have
times 5.
several rows and
Which is 2 less than his answer. Which makes our.
Alright.
Uh-huh.
Oh, it makes sense. It's because he has the 8 times the 2 factorial.
Yeah.
Yeah, okay.
What could it
For that particular.
Oh, which is next.
If I had.
Oh, yeah.
This other one
If I had a
for
grid
as well?
organizations. So, I mean, you gotta have things that way.
Alright.
That was my grid.
Oh,
Get it now.
So that,
Oh.
yes,
What?
because then your, a lot of your format is 0, 1, and a half.
Yeah, that's what I'm.
So you don't have as many
Yeah.
zeros sticking around, it's just.
No, it makes sense. No, right, because it's 9, but it's 9 times 2 factorial. So if it changed to an 8, it's used.
Yeah, there would be that R, R1, 2, 3, all of the.
That was right.
R
He
values.
said he made a mistake.
Oh.
Yeah,
Right, so R3 would be 0, R4 would be 0, automatically. The and half would be violation, and the and half. With only 2 rows.
So you want to challenge yourself, you can do it.
That just makes your life easier.
Yeah.
So.
Now, even now, it's like it's not 3, 4 combinations. 9. Be a bit lower for that one term, but other than that, you're gonna get it.
150.
That would make sense. That would make okay.
Oh, so it means that bottom 3 are violations.
Yeah. All these are.
Oh, you flipped it.
I mean, I was just trying to think, like, so, I'm trying like a leaderboard,
Yeah.
right?
Yeah.
If you make it like a leaderboard, I think it makes a little bit more sense.
Okay.
And then Morgan Wallen is either 5 or 6. Morgan Wallen, so he cannot be in 2. Kenny Chest is the first, third. Kenny. Oh, okay, so we only have 4 that's.
So can I make a suggestion here?
Yeah.
I like your reasoning, but you know, if it's a leaderboard,
Yeah.
vertically. But when you have, some straight empty rows or columns, it's nicer if they are rows, because then those are, those terms where you're doing violations, you have it in those particular, see, now you're gonna have to calculate one, R4, R5, and R6. And if this was turned on its side, then you can't have more than 3 violations, so the R4 is 0, the R5 is 0, the R6 is 0. So this would be a case, you could transpose these pictures and it'll yeah, so I would just put the names of the people here and the numbers there.
My real world application built. It's all figuring out. That's Was this
I don't know,
Actually, Lake Shelton was not, we. What are both the numbers? Two more, and the other one was. Two more.
Can I make a suggestion?
Smaller, adding 5 or 6. 5 or 6.
No, yeah, it's fine. The problem with this is that we have to calculate all of the odds. Or 1, or 2, or 3, or 4, or 5.
So we only need to worry about. The 5 times.
Okay, so
This would have been transferred horizontally instead of vertically. And that would mean you would have not 3 columns.
Violation.
yes.
Yeah. I would say here.
Actually, now that I think about it, if we had it the other way, we'd have at least had a lot of zeros.
Because there's only 3 of them that have any X on them at all, and you wouldn't be able to have 5, 4, 6. Down and just figure it out. I would recommend, as long as it's the same answer, because the number of solutions.
Yeah, there's 3 after 4 plus 3, 7, 5, 9, 10.
And I guess saying to calculate all these numbers, it will be easier.
Okay, so R2,
It's just easier.
we're gonna do BS. with literally 2. Just a lot. Oh, 1 B, 1 4. 3.
Did you guys?
So 1 3.
You would have made
Pick this. We got 3 choices. Since we picked this, we
basically, if you do.
Pick this. We have 2, 2, 3. That's 7. And then 3, 4. We pick this. We have 3 choices. We pick this. We have 2, 4, 3. Pick this. 2, 3, 2.
It's not.
3. This is 10. That's 10.
The picture, it'll still be the same.
Yeah.
28.
That's it.
Yeah.
Now the triplets.
So we got 10 and 28. Is that right? Yeah, that is what I got. That is what I got. Excellent, excellent.
Is that it? Alright, so we pick this guy. We can pick 1.
But you would have to be all the way from
That's
R1.
1. We can pick this. That's 2. We can pick that.
Yeah,
Now,
I already know.
we just this. this. I lost track already. Alright, let me show you. We start with this guy. We can pick this guy. And then we have one choice, two choices, three. Now we can pick this and this.
Actually.
We have two more, that's five.
Three.
Then we can take this and this.
Oh, you're right.
We have three more, that's.
Oh, yeah, if you're doing
Okay,
that.
that's 8 choices for the first.
Yeah,
one.
you can-
Okay, now for this next, we can pick this,
Okay, yeah,
this,
so you.
and this one choice.
Absolutely.
This,
Looks good.
This is exactly.
That's one,
This,
two, and three.
this,
Drawing on.
this, that's 3 choices. This,
Yeah,
this,
one,
4 choices,
Yeah,
this, this,
Oh,
is 5 choices.
Yeah.
We can pick this, this.
Yeah, it's,
These choices. This is 8.
1, 2.
This.
I know.
This is 9, this is
1,
10.
2.
Okay, then we can pick
We choose
this guy
this one.
with this
We
guy.
have 3
This guy, it's 11, this guy,
Okay.
this is 12,
We choose
this
this
guy's
one.
18, 14, 15, 16, 17, 18, 19. Oh, please.
Which one are you looking at?
Oh my god, it's 21, I got 19.
Okay,
Oh,
I
my
think
lord.
I had that one right, but I'm not 100% sure. It's okay, you know, something like that. Don't lose a lot. I mean, if you know how to do it,
Yeah, I
that's
get it. It's
all
just-
that matters. Yeah. So you got 19, and I'm gonna see if I can do stuff in here.
Yeah, you go ahead
I'm
and
just
count.
gonna use my fingers. So
That's
I'm gonna
fine.
take this X here, and then I have to see how many go with that X. So I can do this one or this one, that's 2, or I can do 3, or 4, 5,
Oh, yeah.
and that's it. With that X. So 5, so
That's what I
now I
have.
pick this one together with 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 plus 9, that's 14.
Gotcha.
Now I'm gonna do this. So this one together with however many I have here. 1, 2, 3, 4, 5, 6.
14 plus 6, 20.
I said it's 21.
You said it's 20. And I got 19. It's a mess.
Maybe it's supposed to be 20. So. Let's check that. I'm pretty sure that would only be 20. I gotta fix my suit. I didn't show enough work over here to be able to. But you get the I think 20.
Let's go with 20, guys.
I think 20, I was pretty careful when I did it. So I could trust myself, but.
Okay, so it's 5, and then.
Again, one,
5.
That's 5.
that's 5 total.
5, 6.
5, and then this guy, 1, 2,
You can do this one.
4,
You have 3.
5, 8, 9.
Wait a minute, wait a minute, I think 10.
I mean,
With this one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is 5 plus 10 plus 6? Hello. And I.
So I realized, I think those are the 2 I missed.
Yeah, I think so, Anyway, not a big deal. not a-
Alright, 21.
I think it's work.
Okay.
And then the rest is.
Let's do it.
How do we define it?
It's because those rows are not, they don't have actual not part of it, that's fine. There's no violation, it is 0.
Awesome, good job, good job.
Alright.
Yeah, I know. Now it's time to go to bed. Scroll that.
I know blood. Not lost. Oh, my God.
So you don't need to write all of it.
Alright, guys, you guys ready for the 10 by 10 exam? One question. Just a 10 by 10. And there's gonna be a violation of each row.
You're gonna be like on like the 7,
the 7 groups. Like, we're getting.
One violation, at least one violation.
Hey, guys, can we all come back together for a second? I have one little typo on my answer key, which was on number 1. I think the R4 should have been 8 and I wrote 9. So I'll fix that, but most of you figured that out. Does everybody feel like they got this down?
Yes.
The one thing I wanted to say, sort of from a concept point of view, because if I give you a word problem, there is no natural preference for how to set up rows versus columns. So on this music example, right, some people were putting the singers on one side and then numbers of their chart position of their songs on the other side. So they were doing rows and columns in one configuration, but there'd be no reason why it would have been either better or worse to have done it the other way and put, say, the singers on the top, with the song positions on the side. So there won't be any clue just from the question itself as to which way is better, but there might be a better way. And what I was telling, I talked to some of you about it, but in case you missed it, if there are columns that are completely empty, you should think about whether it would be helpful to transpose your grid and interchange the roles of the rows and the columns, because empty columns are not as helpful as empty rows. Because if you have empty rows, that means you have less of those R terms to calculate. Okay, so just a suggestion. I think most people eventually got around to seeing that, but I just thought I would mention that. I don't think I'm gonna start the next chapter right now. It seems kind of silly to do that. Can I just do one little problem from the review packet? Somebody came to my office, and then we'll maybe quit 5 minutes early today. Somebody came to my office and asked me about one of the problems from the review packet, and I thought it was kind of a clever problem. So I don't know if all of you have looked at it yet, maybe not. But this is just a little random problem. How many ways are there to arrange 8 A's and 10 B's if every A must be followed by a B? So this is kind of an interesting problem. Oh, good, we have this set up. Good, thank you. So this is essentially off of the review packet. So you're making strings of A's and B's. By the way, if there were no constraints, I always like to ask that question. If there were no constraints and it just said, how many ways are there to arrange 8 A's and 10 B's? What would the answer to that be?
You would do 18 choose 8 or 8 choose 10.
Exactly. You'd have 18 slots. You would choose 8 of them to put the A's in. By default, the remaining slots, there'd be 10 slots left. You'd choose B's for all of them. There would be no choices, essentially. This is really the Mississippi problem. And we've seen that a lot, right? That kind of problem where you have, a string of letters where there's certain repeats of each kind, right? So this is the other thing I like to do with my exam questions is, kind of have 3 or 4 tweaks of some, I'll usually start off part A is like no restrictions. And then I might give you a B, C, and D, like some additional parts where I do some little tweaks. Kind of like the fire trucks example or the photos with the bride and the groom example, right? You remember that? So like some of the group works that we've done. By the way, it's not a bad idea to review the group works again. We've had 6 of those now. But this one's a little different, actually. It's actually a little trickier than you might first imagine. So the point here is that I'm going to have this string of A's and B's, but I must put a B after every A. Now, another way of saying that would be you cannot have 2 A's in a row. Because as soon as you have an A, then you have to have a B. right? But it's not quite that simple because even if you don't have two A's in a row, if you have, you can't even have an A at the end of your string. You have to end with a B. Okay, so, you might be thinking about like, could I subtract violations here? I could take the 18, choose 8 and subtract off those strings where there is an A that's not followed by a B. That would involve either two A's in a row or something like this. Or it could be both. Or you could have like several of these. You can see like, you know, this is a violation, but so is this and so is this. I don't want to count this more than once, right? If it sounds really convoluted and complex like that, chances are it's not probably the best way to do the problem. If the violations are going to be harder to get my hands on than just answering the question directly, maybe we should just try to answer the question directly. So if I was doing a direct solution to this, right? What you might be thinking about is, all right, every time I lay down an A, I have to follow it with a B. Now, I could put another B here or an A here, I don't know, but somewhere along the line, I'll have another A followed by another B. And I'm gonna have that show up actually 8 times because every time I have an A, I have to follow it with a B. So I'm laying out, not very well, don't have enough room. 1, 2, 3, 4, 5, 6, 7, 8 ABs that are kind of being, you can kind of think of them as being glued together. And you can also kind of think of them as that you haven't made any choices yet. You just like spread these letters out, but it's not like you've chosen to put something somewhere. You just know that these are all gonna be lined up somewhere. Now, there's still 2 more Bs, right? Because there's 10 total, 8 of them are already up there. So where the choices are coming in is where you put the rest of the Bs, right? And so what could you do? You could put them both here. Or you could put one of them there and one of them there, something like that, right? Or you could put, you know, one of them at the very beginning and one of them at the very end. You could do something like that. It's very confusing. So the question is, how many ways would there be to choose where you're going to fill in those 2 Bs that you have?
Gaps.
I could put them both here, I could put them, so you could do this in 2 ways. One way would be, you could say, well, how many ways are there to put them both in the same gap? So there's a gap here, 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 here. I think there's 9 gaps, including the outsides. So you could choose to put them both together in those same gaps, or you could
Double count them.
choose 2 of the 9 places to put the B. So I think one way to do it would be to say there's 9 ways to double them up, plus 9 choose 2 ways to choose 2 places to put 1 B. Right?
Yeah.
Sorry, I'm talking, I get excited. So when I'm gonna put 2 more Bs into this string somewhere. I could put them both here, 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 or here. That's 9 places. And that's this. So this would be both extra Bs together. Right? My other choice is to take those 9 gaps and put 1 B into each of 2 of those gaps. So I would choose which 2 gaps I was gonna use, and I'd put the 2 Bs into those gaps. So choose 2 spaces to put 1 B each. And you could do that. That makes, I'm gonna give you another way to think about it in a second. But that's one way to think about the answer. That would be fine. This would get a little harder. What if there were 11 Bs or 12 Bs? And I made this question, then you'd really not want to do, well, I could put all 4 of them in one gap, or I could put 3 in one and 1 in the other, and you'd get a lot of cases and it'd get messy. So there is another way to think about this. That's a little different. Say it again. Stars and bars. Could we think of it as, here's how many Bs I put in this gap. Here's how many Bs I put in this gap. Here's how many Bs I put in this gap, and there's 9 different places where I have gaps, but in total, I'm only gonna end up with 2 Bs, right? So I can either do like 2 plus 0 plus 0 plus 0 plus 0 all the way across, or I could have 2 different ones in here somewhere. And this is stars and bars with, how many stars do we have here?
You have 2 stars.
2 stars.
8 bars.
How many bars? 8 bars. And so, and are there any constraints? I guess each of these is at least 0, and there's no maximum constraint. So, I mean, I could make a constraint by saying you can't have more than 4 Bs in a row or something. And then it would get, well, actually, that could never happen. I could say you could never have 3 Bs in a row, and that would create a constraint that you'd have to subtract out. But anyway, the way this is set up now, it would be 10 choose 2. Can anybody confirm if these are the same?
Yeah.
Oh my gosh, that looks like the Pascal formula. N choose K is equal to N minus 1 choose K plus N minus 1 choose K minus 1. I love it. That's another good thing to know for next Tuesday, the Pascal formula. I just tied that in there perfectly, didn't I? Yes.
I was thinking you could just think of the pair AB and then letter C, and then just do a restricted problem with 8 Cs and 2 Bs.
Yeah, you could just do that too. You could just relabel the AB as something else. Yeah, exactly. All right, well, so much for finishing early. I had so much fun doing the problem.
Minus 1.
Oh, the Pascal formula?
N minus 1 choose K.
Everybody knows this one, right? N choose K equals.
N minus
So
1.
I do have
Okay.
The second part's where I messed up.
I might have like
K minus. That's the second one.
Yes, that's it. That's it.
0 or 3.
Guys, I'll be around. If you got questions over the weekend, shoot them off to me. If you got questions on the homework for tonight, I'll be around.
Or you like.
And I will see you guys again soon. Kind of a neat problem.
It's like they're all in.
Yeah, I mean, they are the same. Like